Hello, hi, how are you? Can you hear me? Hello, hi everyone. Kindly let me know if you can hear me. Just type in the chat. Still giving a few minutes for the rest of us, for the rest of the people to join us as well. Okay, welcome everyone. So we'll start in the next 2 minutes, and so we'll start at the 1:15. So welcome, guys. So Kevin, Jakai, Fidel, Emmanuel, welcome. Gerald as well. I'm seeing I have a namesake in the call. Pretty interesting. Yeah. At least I've interacted with some of you in the previous sessions. But I think I also get to know you a bit more today. Just a quick update. Apologies on the session not being able to happen yesterday. Alicia, David, who took you through day 2, was feeling unwell, so he wasn't able to take you guys through yesterday's content, but I'll be able to cover that today as we continue as well. Okay, I think we can get started. So welcome to effectively day 3 of the Solidity Bootcamp. Maybe just as we get started, I'd like to hear from you guys. Just a recap of what were you able to cover in day 2, and what do you remember in terms of what, sorry about that, in terms of what you were able to learn and how you basically interacted with Alicia during the session. So feel free to unmute your mic and just let me know what did you guys cover and what key learning points did you have. So anyone can go first. Feel free.
Hello. Hello.
Yeah, hello, Emmanuel. I can hear you.
Okay, yeah. The last section was okay. So he talked about data types. So and we get to see those in action. I mean, it's more like a refresher to me, and particularly the struct data type, which can be used to, I believe, create your own data type for any object you want to have. So let's say you want an object that could at least contain more than one data type, store a particular information, using example book. So then we also discuss about other data types and how to use remix. How to get we started using remix to interact to to showcase some of these data type in action. So that's basically what I recall we did, and it was very much okay.
All right, awesome. Thank you for that. So other than data types, what else did you guys cover during the other session you did?
Okay, basically it was using Solidity, programming Solidity on Remix, being able to deploy your code, choosing your version, the version of Solidity you are using, deploying it, and then interacting with it with probably with the get functions you have on your contracts.
Okay, awesome. Thank you. Maybe I can also open it up to everyone else. Were there any specific questions from the last session that maybe some of you may have had?
Not really. We don't have any more trees. Okay, the one we had, he did well. We did well to answer it and get to see it in real time. I think one question someone asked was uh, particularly on struts. If we can, because we are trying to we are trying to store a variable. Okay, we created a strut and then store a variable to it. So one was asking if there is any way we can pass in we can create objects, the struct object, we can create multiple times instead of having to create it once. So I think we try to use a function to actually do that. But at least I would love to more I would love more on kind of how do I really put this? Find how to kind of using your function to populate or to create more structs and then be able to fetch them. Like, okay, let's say you have a strut, then you want to create more objects of those struts. You being able to use a function probably to create those ones and then be able to get it back.
Okay, so if I get you
I don't know
correctly,
if I can okay.
just if I get you correctly, what your question was, so what that person asked was in terms of, can you use a function to one, create more objects of that struct, or is it that it's a function that you use to create more structs within the contract? Which of the two is it specifically?
The first the first one you see will
Okay.
define the first one. Being able to create more objects of the struct using a function
Okay.
other than hard coded objects.
Yeah, that's true. Because the struct is more like a blueprint per se, and how it's mostly used often, more often than not, is each smart contract that you write has something that acts kind of like a constructor. So that's where you basically initialize and those specific objects based on the blueprint that you set. So the structure itself is mostly just that exactly a blueprint that you can now use in any other function, not just one specific one within your smart contract to create and manipulate those objects. It's just that the best practice is to create those objects once that particular smart contract is called, rather than when, how do I put it, than in any other particular function, just in terms of security and data management. Remember that your data stores are not infinite within a smart contract. So it's best to create those objects at the beginning of your interaction with it, such that it's also more efficient. That's part of the thought process behind it. But yeah, that was definitely a very interesting question that came up. Was there any other question from anyone else from yesterday's call that we can also just discuss briefly as we go on? Oh, sorry. Hello, Ellie. I think you have a question. You can go ahead. Okay, I'm assuming you're all right. Okay, so I'll also let Alicia say hi to you guys since he's also in the call, maybe before we continue. I don't know, Alicia, can you hear me? Okay, no worries, that's fine. So before I share my screen, there are a couple of things that we are going to discuss. during today's class. Firstly, it's just in terms of building on top of what you were able to cover yesterday when you're talking about the basics of smart contracts. I'm going to talk about two new concepts specifically, namely mappings. This is mostly to do with the address data type as well, which will be interacting it more as we continue. Then secondly, in terms of functions, specifically in the Solidity or in the smart contracts setting now, such that you know exactly how functions work and how to set them and create them as well. The other thing we'll be covering is, I'm assuming that most of you, maybe this is your first time interacting with smart contracts. So I'm going to give a brief recap of what we covered in the past 2 days, just like in 2-3 minutes. Then we'll get into how do we set up our wallets, or for example, Metamask on our browsers, and how we can connect them to Solidity in order to deploy and actually compile and then deploy smart contracts as well. Then finally, you'll also be going through how to connect your testnet to your MetaMask wallet as well, and how to receive tokens to your testnet wallet address. That's not in terms of the first part. Then secondly is I'm going to give you guys a brief rundown of the difference between different frameworks and tools that we use when we're writing smart contracts, namely Truffle and Hardhat, and maybe what are some of the key differences as we continue as well. Then finally, we do have an assignment that we've set up for you guys just to gauge and see how well you've been able to internalize the content that we made able to share, and also just as a practical exercise to see what you guys can come up with. And I'll give you a rundown of how that looks exactly. All right. And also the deadline for this will be midnight next Saturday, which will be on the 16th. So you have a week to work on it and research and play around and see what you guys can come up with. And you can only receive a certificate for this particular training once you've completed that particular assignment as well. So before we get into it, are there any other questions for me before I get started? Okay, I'm assuming that you guys are good to go. So let me just go ahead and start sharing my screen. I've seen a couple of more people have joined us. Welcome, Sammy. Okay. Okay, do let me know if you can share, if you can see my screen. Hello, can you guys see my screen? Okay, assuming we're good to go. So since thankfully you're able to go through how the Remix IDE looks with Alicia on Thursday, So what we're going to be doing firstly is, I'm sure you talked about structs and about, let me say, the different data types as well. But then I don't think you talked about the logical. Okay, I'm seeing that you, apparently you can't hear me. Okay.
I can hear you now. I can hear you now. It's clear.
Oh, okay. Okay. Thanks. So, okay, I think that's fine. Yeah, so saying you covered structs, you covered data types, but I don't think you covered stuff like arithmetic operators and the likes. But I think it's pretty straightforward. So maybe before I get into functions and other things, I'll just run through this pretty quickly. So I think the first thing I need to do is maybe just talk about just some of the operators that you'll be interacting with. If you're already a programmer, trust me, you're good. These are things that I think come second nature to you, but it basically works the same way as anything else that you've interacted with. So for example, with this particular variables, as you can see here, basically if you have an unsigned integer, which I believe you know what that is from yesterday's class. It's basically an integer that doesn't have a plus or minus sign when it's stored within a variable. So if I have A and B in terms of the arithmetic operations that we can do, you can add them. As you can see here, you can subtract them, you can multiply them, and you can divide them. The only thing that I wanted to highlight briefly was just these three things. Most programmers may be aware of this, but these three operators are what you'll most likely be using, maybe if you're coming up with things like loops or if statements as well. So the first one being the modulus, which is more like a reminder in terms of the divisions that you make. Then this one, so instead of having to do, what's it called? Like b minus 1 all the times, you can basically just have this notation, which is two minus signs, then the b variable, just to decrement a value within that particular variable on its own. Then the opposite is true now with the increment in terms of a plus plus. It's something brief, very simple, but I didn't want to assume it. I just wanted to mention on these three as we continue, because sometimes these functions work differently depending on what smart contracts programming language you're using. But in terms of Solidity, it's pretty simple, straightforward, similar to how it would work in stuff like JavaScript, C++, and the likes as well. So it's not anything too complicated. The only other thing I also wanted to briefly go through and highlight will now be, let me even just change this. So those are now the numeric operators within Solidity, but I'll just go through, let me see. So A5, okay. So I'll do this 8. Yeah, I think that's fine. The error was because the version was less than what is specified in the configuration file. So it has to be Solidity version 8 and above, basically. So with that, we are good. So we've talked about the arithmetic operators, but then there's something we also refer to as now the logical or operators as well within uh, the Solidity environment, but then there's also something we refer to as the relational operators. So I'll go through relational first. We call them ops, then logical. So maybe before I get into this, because I want it to be more of a discussion, I have a very deep voice. If you guys listen to me for 30 minutes, you can also start getting a bit bored. So I wanted to ask, for the guys who have some programming experiences, when I talk about relational operators and logical operators, what comes to mind for you guys? I think I've heard from Emmanuel. James, how are you? I see you've joined the call. Maybe I can ask you this question. Between when I talk about relational operators or logical operators, what else comes to mind for you?
Hello, can you hear me?
Yes, I can hear you.
Okay, when you talk about the logical operators itself, let me start with the relation operators. These are operators that mainly they measure in more like comparing variables. Let me say when you initialize a public variable, let me say a as a u hint 20, b as a u hint 10. So when you introduce a logical operator, relation operator, for example, equal sign is a logical operator. It's a relation operator there. It compares the variables. Logical operator on the side. The logical operators more like not you try more like to compare so comparison skills. Uh, we use and or and the and those logical ones.
Yeah, thank you. That's true. So what I'm gonna do is I'm gonna come up with a new variable of type Boolean. So we're gonna just be explaining the different operators, but I'm gonna be asking each of you a question in terms of what result you expect based on the operator that you see here. So for example, I'll create a variable called bool public. Then what do we call it? Let's say equation or EQS. Then I say A so what this value or what the value that will be stored in this variable will be the what's it called? The true or false statement based on this particular operator. So maybe if I was to ask, let me just go with how the names are written. If I was to ask Emmanuel, when you see this equation that says the variable EQS is equals to A equals to B, what value would you expect as a return from this variable?
It return okay. It will return a Boolean value and that should be false.
Yeah.
That should be false.
Why would it will be false? Why?
Okay, because we are actually trying to compare that the value stored in A, if it's equivalent to the value stored in B, and obviously they are not the same. So it will evaluate to false. And obviously we've been told before now that that Solidity is a static type or static type language. So we need to declare the variable that is going to be stored on that EQS. So since we declare it to be a Boolean, it's going to store a Boolean value,
Yeah,
and that is false.
yeah. Then similar to that, so basically based on what you said, so if I do this instead, which is now the basically saying check if A is not equals to B, based on your explanation as well, it would return true because the values are different now as well.
Yes, that is true.
Yeah. Then maybe I can also now head over to someone else, maybe Mark. I don't know, Mark, if you can hear me. So if we do this sign here, what return type or what value do you expect to be stored in the variable, Mark?
I think that will be true because A is greater than B.
Yeah.
Yeah.
Yeah, basically true. And the opposite is true in terms of if I do the other sign. So if it's less than, it will now return false because A is not less than B in that sense. So the operators are fairly straightforward. The only other thing that would change now for the relational ones would be adding the equal sign, which basically says now it can either be greater than or equal to or less than or equal to. So greater than being like this, then less than being like so. So that's something that's pretty straightforward. That's similar to all other programming languages. So in terms of the what's it called? The relational operators, that's pretty straightforward. So for the logical operators, I'm gonna create a function, and so as I'm introducing you guys to functions, I'm just gonna be using the logical operators as well. So I'm gonna type something out here briefly, or just to give you guys a view of what we can do. Then I'll also share a link for you to read something more. So I'm only going to introduce the logical operators and functions, but there's also the whole concept of control flows and Solidity, things like how do we make decision statements within Solidity as a programming languages. And this mostly deals with things like while statements, do while, and for loops as well, which is now more of the recursive part of programming languages. It's pretty straightforward, and it's also kind of interesting for the guys who are into algorithms and stuff in terms of how you can manipulate this. But since it's purely beginner, it's best just to have a basic grasp of them rather than going too in-depth. I'll share resources for you guys to read more on that as well, just to get up to speed. So let me check this out. So I'm still going to use the variables A and B for this particular example as we continue. Start with that. Finish this. Then I won't initialize them, I'll just leave them as that for now. But I hope you guys don't mind me typing out functions. I really don't like using slides for the practical parts of these sessions. So if it's a bit slow, forgive me for that. But also you have the space and the room to ask me questions in between as we discuss it as well. So there's also no worries about that as well. So as I continue with that, the next thing I'm doing now is just to create the function that we're going to be using to manipulate this. So now that we have the two variables, actually, let me put them in the constructor, not the constructor, in the function itself, rather than putting it above it. So if I have a function called, we said logical, so logical, let's see, bool, internal, then bool internal b. So based on what you guys are able to see on the screen, Let's see if I'm going to ask the questions. Let's see who hasn't spoken.
Sorry, I can't see your screen.
Oh, okay. Let me see what the issue might be. How about now? Are you able to see my screen?
No, I can't.
So let me try and share again. How is it now?
Yes, I can see.
So, okay, let me just explain what I was doing. So, I've created a function called logical that takes in two parameters, two Boolean variables of type A, or not type A, of variable A and variable B. So in functions in Solidity, you need to define how you want to interact with data. So if it's internal, it means that this within the specific function is when you'll be able to interact with this particular information. Then for the return type, you need to also specify whether it's public in terms of who can access it as well, then pure in terms of its mutability. So if data can be changed or manipulated within this particular function. So if you don't specify whether the return type can be public, you'll have errors within your specific functions. Don't worry, I'm just mentioning it now, but just after this, I'm going to go through functions specifically. I've just put it there such that as I'm giving you the rundown of the logical operators, you're not seeing any error messages, which might be a bit confusing, but I'll explain what exactly is happening in this first line as we continue. So you don't need to worry too much about that as well. So these are basically the three logical operators. There's the AND operator, the OR operator, and the logical NOT operator. So in terms of the results here, I'm just going to ask each and every one of you what you think the variable being returned would say based on this. So maybe if I say that, I'll start with, let's see, I'll start with Kevin. Maybe I say I have the variable A and the variable B. I say that A is true and B is false. What value do you think I would be expecting to see in this first variable for AND? Kevin, I don't know if you can hear me. Yeah, go ahead.
I think it should be false.
Yeah. Why do you think so?
Because for the AND to be true, that means that either A and B are true. Yeah, I think that is the only criteria. A and B are true for the Boolean AND, for AND results to come out true.
Yeah, that's
as a comparator.
Yeah, that's definitely true. So the only other question I would ask is, this is a rhetorical question. I want you guys to think about it on your own. What value would they expect if I say A is false and B is false? Just think about it. If you have an answer, you can also feel free and tell me, but I wanted to ask just so you guys can also just pick your brain a bit. Emmanuel?
Okay, it's actually true. So it's untrue.
Does anyone else have a
You say
different?
hello.
Yeah, I can hear you.
Okay. You said when both of them are false, what is going to return? It's always going to return false.
Yeah. Does
Yeah,
anyone
it's
else
always
have,
going to return false.
Does anyone else have a different thought? It's an interesting question. Anyone else have a different answer?
Can you come up again with the question?
Okay. Sorry, sister dropped. Let's see. I want to share this link with you so you can also read more about it from W3 Schools. But my question was basically in terms of if it's both A and B. If A is false and B is false, what response do you think you guys are gonna get?
It should be false. Now, aside that with and anything that if any of the options is false, then the results will be false.
So it only returns true under the condition that both A and B are true.
Yeah, absolutely.
Okay. I'm seeing someone else has written something in the chat. I'm seeing something from James. So the answer is false. Okay. I think you guys have a consensus. So that's basically it. So I think if I continue with the issue sharing. Okay, so, and I think based on what you guys have said, the OR operator is basically the opposite of that. So if I say A is false and B is true, what do you guys think would be the result, would be the return?
For the OR result, I think to be true.
Yeah, basically that. As long as one of the values is true, it's going to return true. So that's the only difference. And finally, in terms of the last one that you're able to see there, is if you have a not operator, it basically tells you check if the value of A is what not equals to true in that sense per se. So those are now in terms of the logical operators. I want to share this link with you. The examples I was using was from Geeks for Geeks because I think they're the best in terms of being able to get something simpler, because the smart contract I'm going to show you guys is one that I came up with on my own. It's related to the assignment. So it might be a bit complex as we continue. So I wanted to start off with this easy one just to jog your memory a bit. But if you want to learn more about Solidity in general, I think I'd recommend Geeks for Geeks. But from my experience as a dev, the best place is always the original documentation for Solidity, which I'm also sharing the link to right now. This is something that I learned on early as I got started with writing smart contracts. So even just being a backend dev in general, don't rely so much on YouTube tutorials and maybe Gigs for Geeks. Yes, I'm sharing it because it's easy to get started. Maybe if you're not that experienced, but eventually you need to grow out of these particular websites because they lock your creativity in. And also there's a lot of interesting stuff that you're going to miss out. So the best thing is always go directly to the docs. You'll be able to see a lot more details in terms of what we will be able to cover. So don't be scared of reading. After a while, it gets pretty interesting in terms of the things that you're able to see and find out as well. So that's it in terms of all of the operators. I wasn't sure if you had covered it yesterday. That's the reason I was going through it now, just briefly, just to make sure that everyone is up to speed with that as well. So now I'm going to open up a different workspace here. Yeah, I'm going to start from here. So what I'm going to walk you guys through first is now setting up your MetaMask wallets. So maybe before I continue, maybe by a show of hands, is there anyone who doesn't have, what's it called, a MetaMask wallet set up on the browser? In case anyone, so I know if you guys already have it, you can skip that step. I can just go straight to connecting it to the testnet. But if there's anyone who doesn't have it, I can just walk you guys through it pretty quickly. So maybe you can just raise your hand if you don't have this wallet. Okay, nice, awesome. I'm seeing most of you guys have this already set up. So you can walk through it. Okay, second question is, are any of you connected to the Goerli test network for Solidity? If no, just raise your hand in the chat as well. I would be surprised if you have, because I think you guys will be way more advanced in that sense. I think we can get into the in-depth stuff pretty quickly. But if not, just let me know. Wait, so all of you guys are connected to the testnet? Okay, Mark is not. Okay, that's fine. Since one person isn't, I think you can go ahead. Now, this is the part I hate. I always forget my password for this thing. So let me see if I'll get it right in the first try. Okay. Okay. Perfect. Actually got lucky for once. So you guys can follow through this with me as we continue. So if there's anyone who wants to do it with me, I think that would be the best. So now that I've set up my, what's it called? My test network, the next thing I'm going to do is connect it to the Goerli Testnet. So I'm going to go to this website called Chainlink. If you are part of the Solidity Bootcamp, you already know what exactly I'm doing. But for those of you, actually, I don't like chain. Let me do .xyz. Okay, but .org is still fine, no worries. So what I'm going to do is, Solidity has a number of test networks that are managed by different stakeholders. So you'll find some like Goerli that we'll be using for today. Then sometimes you'll use that. There's also one called Optimism Testnet for different types of Solidity testnets and chains and stuff like that. So there are multiple of them. I'm using Goerli because as you continue your development journey, it's the most common one that you will be interacting with as we continue with this particular bootcamp, and also even in your own careers as well. So I'll just search for it here. I hope that's the right spelling. Okay, search. Include testnets. Okay, so here we go. So this is just giving me information about. So if you search for Goerli, you'll find different views. So you'll have the ZK sync era Goerli testnet, which is, as it says, it's depreciated. Then there's this one. Then there's one for optimism. There's one for Metis. There's one for Bedrock. Then there's one for Base, the Base Goerli testnet. So let me just open up to see different stats about it. Then there's one by Arbitrum. So I'm going to take a bit of a tangent here to explain something. So how Ethereum works is there are those layer 2 solutions that enable the scalability of Ethereum to continue to grow, meaning that you can make or you can push transactions onto these level 2 or layer 2 chains, which will then confirm them and create blocks and publish them to the main net or main testnet in this sense, because it makes it faster for transactions to be validated and also making it cheaper for your gas fees as well. And there are two ways of doing this. There's a zero knowledge proof or the ZK rollups, because what these scalability solutions are referred to as is rollups. So for the zero knowledge proof, what it does is basically the mainnet trusts that this ZK rollup, for example, the one that was listed here, although it was depreciated, I'm guessing, this one for sync era Goerli testnet. You see this ZK, it's very zero knowledge proof in that sense. So what happens is the layer 2 chain, sorry, creates a new block of transactions. This new block of transactions is validated. Then a cryptographic hash of this block is created. Okay. So far until there, are we good? Just raise your hand if I've lost anyone. So at least that I know. Because sometimes I can end up rambling on. So I don't, Emmanuel, are we good? James, Nicholas, Mark?
No, yeah, we are. I had so many questions to ask, but until I will wait for the actual time to ask. But we are good. I'm following what you're saying.
Okay, perfect. So that's so I was talking about the ZK. So a block is created on this layer 2. Then a hash of the validated transactions is made. Then that is sent to a smart contract in the Base main chain in that sense. What this chain does is it checks the validity of the hash, saying, are these transactions true? Yes or no? Then, based on that hash, it basically says, okay, the transactions are true, I'm going to add them to the network. And that's how those transactions are verified and how now you can find them on the main chain in that sense. For optimism, it's a more open one. They're like, you know what, you're in the Ethereum ecosystem, points to note, you can read more about this on your own. I'm just trying to summarize it in a way that's easier to understand. But for optimism, as it says, you're a very optimistic person. So you're like, you trust that, or the main chain trusts that, okay, all the transactions that are coming in from this chain are true and they're valid. I don't need to check any cryptographic encryptions to know if there are any transactions that have been tampered with. It just adds them as is. However, the validation, or now that layer 2 that's on optimism, happens within that L2 in a fairly robust way as well. But the technicalities of how that works, I'm not going to get into at the moment. Those are the two different thought processes. That's why sometimes when you look at testnets or different chains, you'll be seeing things like ZK or ZK Polygon, you're seeing optimism and you're wondering, okay, what is this? What the hell is this? That's basically the thought process behind it. So I'll open it up to you, Emmanuel. You can start asking your questions as we continue.
Okay, it's actually now that I get to understand the idea of layer one and layer two. So just trying to rephrase what you say. You said layer two is just the layer that kind of accept the transaction, perform the action, then at a later time write it to the Ethereum network. Right. Okay. So now, getting that, I would want to know more on the zero trust. Like the transaction now, the part of sending it to the Ethereum, is it just for storing it on the database? Let me just use that word, store it on the database. Then the whole verification, validation, ensuring that all nodes agree to the transaction is being done on the layer two. Then it will now write it to the blockchain on the layer one. So that's what I'm trying to understand. Then how does zero knowledge come into these processes?
Okay. So to answer your first question, yes, the validation will happen on the layer two. Then the layer two publishes those transactions to the layer one chain in that sense. So one thing you need to understand is, I don't want to get too much into this because this is now the more mathematical side of Solidity, or of not Solidity, but of blockchain. It's more on the architecture. So what happens is there's a prover in the ecosystem of how a zero knowledge proof works. Then there's a verifier. So the prover in this sense will be the layer two chain, which what it does is it has a function that takes in a specific set of inputs. Then it gives out a specific set of outputs as well. That's now the basis of it. So the input would now, for example, be the data that you get in terms of transactions. Then the outputs will now be what will help you generate now that zero knowledge proof, which is just like a set of data, which is now sent to the layer one chain. And the layer one chain will have a smart contract that acts as the verifier in that particular sense. Okay. So this verifier also has a function within it that takes in the output you've received from the prover, which is the layer two solution. Then that output will go into the function within that smart contract. That smart contract has the functionalities within it that will now help you validate, okay, is this a true representation of the inputs that have come in from the layer two chain? If yes, those transactions will now then be added to the layer two ledger. If not, they will be rejected. So there are a couple of models that come up in terms of the different types of zero knowledge proofs that you can interact with. I don't want to get into it too much because I don't want to lose anyone, because now this is more now on the cryptography side of things, because I think one of my majors for my master's is cryptography. That's why I've read about this a bit more. But the most common one that you may hear about is something called ZK SNARK. It's the one that's used most commonly. I'm just going to type it in the chat. But what it stands for is ZK being zero knowledge proof, S standing for succinct, N being non-interactive, then AR is argument of knowledge in terms of what we are trying to build. So there are different models. There's SNARK, then there's ZK Stark as well. Don't focus so much on those words. You can read more about them after this. But what you need to know is what changes is the components of how the functions are set up to create this particular zero knowledge proof. So I've tried to keep it as simple as possible. Has that helped a bit, Emmanuel?
Yes, sure. Yes.
Okay, perfect. Let me just pause for a bit. I'll take a call. Hello, everyone. Sorry about that. So yeah, that was it about ZKs, zero knowledge proofs, and how they work exactly. Maybe by a show of hands, because I usually do the technical dev hour sessions every Saturday, just about new topics. Do you guys think that me doing a session about going a bit more in depth into ZK chains is something you guys would be interested in? Ah, awesome. Yeah, definitely. So I think I'll also keep that in mind. I'll be able to show you guys the different models and the different chains and maybe the benefits of what they do. Because okay, let me give you guys some backstory for me. I like doing these boot camps to be a bit more personal and realistic. So as much as I work in the blockchain space and I do interact with smart contracts, I have a specific niche. I don't deal with projects as much that deal with things like decentralized exchanges or tokenomics. I'm really big on the security aspect of what you can use blockchain technology to do within the Web2 space. There are a lot of security challenges and policy issues, and I think that blockchain technology can fit into those particular settings. So that's why I focus more on the cryptography side of things, and also in terms of the decentralized identity technologies that are occurring within the blockchain space, particularly in Hyperledger, Cardano, Polygon ID, these types of projects. So I'm more into like the more in-depth tech side of Web3. That's basically, and my advice to you would be find your niche within the Web3 space. As much as learning about Solidity, there's so many things that you can do. It's not a one size fits all. I just feel like most of the people who talk about blockchain are so focused on crypto and NFTs that you forget that at the end of the day, we're all techies. We're all people who come up with different solutions. So my advice to you would be find your niche, find something that really interests you, and go really depth into that particular topic. There are very few people who are specialists in different aspects of Web3. An example is I've talked about cryptography and I've talked about identity. There's a whole aspect about being a low-level blockchain dev in terms of people. We also need people to understand the architecture of setting up chains and setting up infrastructures. There's also a whole gap in that section as well. Then there are also other different areas that you'll be able to discover within Web3, just outside of smart contracts, crypto, and NFTs. It's a very wide space, and I think that's part of what we're trying to do in Memoy, also showing you guys that there's so many different things you can do within the Web3 space. We're just not as aware of it. So sorry, I've taken a tangent talking about ZKs, but going back to the root of what we wanted to do. So we've opened up Chainlist. What I'm going to do is I'm going to set up, what's it called? The Goerli Testnet. So we'll check the base one. I've never used this one before, but we'll just see how it goes. Ikikwama tuta debug, or as in English we say, if it gets stuck, we'll just debug it together and figure out what's going on. So I'm going to go ahead and create a new account. Then I'm going to call it JJK. I'm an anime fan, so you'll have to forgive me. I might as well use that for now. So account 3, let's see, next. So this is now what I was talking about. So when you're connecting to a network, it will come up and you'll find this information, the network name, the network URL, the chain ID, and the currency symbol. So in terms of the currency symbol, you'll find that it's still Ethereum, but the chain ID and these URLs are different. This RPC, or the remote procedural calls, are important because they're what allow you to communicate with the node that will allow you to connect to this testnet. So you can do this manually as well, but I use chain ID just to remove some of that overhead that maybe some of you may experience. It makes things a lot more easier. So if I approve it and I go ahead, error while connecting to custom network. Okay, so what I'm gonna do is let me do this manually then. Or actually, let me see. I might actually find that I'm already connected to the network. I just don't know. So JJK. Let me see if I'm connected. So this is Telos. I'm going to add networks. Yeah, let's add the network manually then. I'm going to call it Goerli Testnet. Let me do this. As well, show you guys the assignment that I have planned out for you as well. So this is the assignment. I'll go over it later, but I just want this detail. It has all the steps of how to do this on your own as well, just in case you're having challenges following along. So these are the details I'm looking. So if I do this as the network name, Goerli Testnet, yep, then this is the RPC I'm going to use. Then the chain ID 5. Or you know what? Let me just use this one. Do this. . Explorer. So another way to do this is directly from the Explorer itself. If there's Etherscan for the mainnet, and there's one for Goerli. So if I open this Explorer, I can also just fetch the details that I'm looking for. The reason I'm doing this is I'm looking for the most official source of these RPCs, because people can make their own. And being a cybersec fellow, I'm a bit paranoid. So I'd rather just see how I can connect this on my own. So let me see if I can click on this. I think it's still loading. So the JS is should be giving me info about the RPC itself. It's,
Hello.
yeah, go ahead.
Okay. From the chain link, I think it lists most of the RPCs on the chain link. Like if you select from those list of ones that are taking green, 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 green.
Let's see this. Hopefully, I think this is the right one. Let me do XYZ. Return XYX instead. Hmm. I think this one was not showing me what I wanted. So what I'm doing is, let me just explain. So I usually use this tool to connect to multiple chains automatically. So I already have a connection to the testnet for Goerli via this particular, what's it called? Via this particular tool. Chain ID. see. Fine. So let's see. So I'll switch to this network. Got it. Let's see. So we have 0 ETH tokens in this particular testnet. So what I'm going to do is just directly, you can always search for the faucet. Directly from here. So then for quick node, I think this is the one that I shared in the assignment as well. Let me just confirm. Yeah, quick node. So what I'm doing is I'm just trying to get some tokens for my wallet that will use for now publishing the specific smart contracts. So what I'm gonna go ahead and do while this is loading is just connect my wallet to what's it called? Remix. The reason I'm showing you the wallet is because I could easily have deployed the smart contracts with any of these testnets that are provided here. But in practice, most of the time is you'll just end up using your own, what's it called? Connection, mostly because some of these testnets are not usually provided by Remix. Remix doesn't have every Ethereum testnet that's available, so it's better just to connect your own wallet. Since that's taking some time, you can also just use Wallet Connect. Since my network is a bit slow today. Okay, so this has opened. So Optimism, Goerli. So let me put my wallet address here. Then we see if you'll receive tokens from the faucet. So this is my wallet address, JJK, copied, paste, continue. Let's see. Well, this is the mainnet. Let me see if I can change to the testnet. But I actually think it should be easier. Okay. So I'm guessing I need to put some tokens here for this to work. I do have some Ethereum tokens that I can send to this wallet. Okay. So let me see if I can send some ETH tokens to this wallet. However, I think it may be a bit of a challenge because my Binance wallet doesn't work because I'm currently in Washington. So Binance doesn't work here. But at least if I was back in Nairobi, I would have been able to do that. So I think I'll just go with the base, what's it called? The base chains that are here. But at least what I can do is I can at least show you just how to connect Metamask. Then I'll switch to another chain that we can use for the particular setting. Because I think my network is still loading. So at least I'm seeing my, okay, wallet connectors opened finally. So what you can do is you can just connect a wallet here directly. You can either scan it or just click MetaMask here. It'll probably do it automatically and we are done. So my wallet has been connected, pretty simple as that, but I'm not gonna use this to deploy my smart contracts. I'm gonna use the Shanghai one, basically the first basic wallet. But the contracts I'm not gonna deploy these ones. So let me just give you a run through of what this is. This is related to the assignment I'm gonna share. So I'm gonna show you how exactly functions work as I describe what exactly is happening here. So first things first is I need to talk about Openzeppelin, which is part of today's agenda. So we've all been learning how to write smart contracts using the basic syntax that is provided. However, one thing that you may need to know is that implementing your own token standards is a bit challenging and difficult. You'll be prone to a lot of issues, a lot of errors, and also it'll be hard for people to interact with your smart contracts if it's a standard that they're also not using themselves. That's why things like ERC20, 721, and 1155 came up, just for specific ways to create smart contracts for specific things. However, those standards also can be implemented in various different ways. So let me give you an example. For the guys who are JavaScript developers here, or even Java developers, one thing that has always been a pain in the ass, okay, personally for me, I don't know about you guys, forgive my French, is that when you're trying to pass messages in the internet from different sources, you need to serialize them in a particular format. So that's a process of serializing or maybe converting data to JSON format. There are different ways of doing it. And sometimes the way one person does it will clash with how you're consuming that data. So instead of everyone coming up with their own way of serializing or communicating with or creating tokens in these standards, Openzeppelin was a library that was created such that anyone can use their library to create smart contracts using the ERC20, 721 standards without there being any conflict. That's basically what has happened. And in terms of how you interact with them is now what I want to talk about here in terms of the specific imports. So Openzeppelin has these particular imports for the contract standards and everything else that comes in with it. Let me share the link to the Openzeppelin wizard. So you can also read more about them yourselves, but it basically makes it simpler. So let me share this on the chat. Then there's also the Openzeppelin wizard, which basically just helps you to create smart contracts from a basic template. I think I went through this briefly in a number of dev hour sessions, as well as during the Telos Bootcamp. But for those who aren't able to take part in either of those, basically, if you want an NFT smart contract, Openzeppelin is the way to get started. Or you want a normal token smart contract, Openzeppelin will also help you to do that. So for mine, I didn't use Openzeppelin to create this, but I'm basically just using it to give you an example of different ways you can implement the different things that you've been learning in the previous session. So obviously, if you import Openzeppelin, what happens is you create your own smart contract. Mine here is called Craftly. What I'm going to do is, I see the contract, Craftly is ERC, URI storage. If this was Java, this is kind of like saying my smart contract extends this ERC 721 storage contract such that I can use the functions that are in that contract within my own smart contract. That's basically what's happening here. Then beyond that, I'm creating my own, variables, or my base variables for this smart contract that I need to be constant and that I need to use to keep track of what's happening within my smart contract. So this is a counter that I'll be using. It helps me count the number of operations that have happened in my smart contract. How many NFTs have been minted, how many have been sold, stuff like that. And in this case, I'm using it for tokens. So I've created a variable of data type counter in that sense. And it's private and it's called token ID. I've also created an address called the marketplace contract address. This means that all the NFTs that I'll be creating will be stored in this particular marketplace smart contract. And for me to do that, I need to know, okay, where is this smart contract located? And storing that address here helps me do that. So in my setting, as much as I'm going through the NFT one first, because it's the longer contract, this one is pretty, actually it's a shorter one, I mean, I'll have to publish this marketplace first, get the address, then I use it to publish my Craftly NFT smart contract. And when I publish it, remember how I said when a smart contract is called for the first time, it has to have a constructor. And in my constructor, the value that I take in is the address of my marketplace smart contract, which will then be stored in this variable here. And this is something that won't change. This is permanent for the rest of this contract's life cycle. Then I specify that this is for creating ERC 721 tokens, which are now NFTs. And the NFTs are of this type, or not type, have this name, and this is the symbol for that particular NFT. So that's for the constructor. Before I get into the specific functions of minting, how you can do this with the Openzeppelin wizard, let me share this with you as well in the chat. It's basically plug and play. I say, what type of token do I want to create? Is it a normal token or is it an NFT? In our case, it's an NFT. Okay. So I come and I do 721. And what do I want the name of my token to be? Maybe I'll say Solidity Bootcamp. From Solidity Bootcamp, I say, I want my token to be SBC for Bootcamp. The base URL is optional. So I'm just going to leave it open. So what I'm going to say is, so what now features are the functions that are here. So I can make it such that this smart contract can mint new NFTs. That's what it means to be mintable. Then, if I want to generate an ID for each token that is minted, I can now say auto increment IDs. Similar to how it works in SQL databases, auto increment means if it starts with 1, it's going to go to 2, to 3, to 4, to 5. But in this case, I think there's some element of randomness that is added because it's not secure to have numbers that people can guess, like 1, 2, 3. So you can also have things like UUIDs, which are unique identifiers, which is a random length of string and characters that anyone can generate randomly, but they can't be guessed that easily. So I'll go ahead and I'll say auto increment. And naturally, as you can see, the constructor here says, okay, when I create this smart contract, I need to know who's going to own this smart contract. And the person who owns it is the address that I will pass as we create this smart contract the first time. The other thing would be, this is the token stand that I'm making. So Solidity Bootcamp is the name and SBC is the symbol. Then this is just a trait that we've added for. Since it's ownable, the initial owner will be this address that we've passed here. Automatically, if a smart contract can be used to mint tokens, that means that it should also have someone who owns this smart contract. It's just a rule that has been set. Don't think too much about it. Then burnable means if I want to be able to burn tokens or basically get rid of them completely, I can type this, then the burnable function is, or the contract is also imported. Then it's now being able to implement it in this particular smart contract. I can also pause the use of this smart contract if I want, using now the pause. Let me just get rid of this AI assistant. I don't know. Yeah. So we see it also imports this contract for ERC 721 being able to be paused in terms of what is happening here. So you can pause it, then you can unpause it, then people can use it. Then you can also update the values of each token. Maybe you want to change the owner, you want to change the price and stuff like that. So once you're done, you've basically created your first smart contract. Very simple. And the next step or advanced step would be to customize this to your own needs, which is something that as you continue reading the documentation and testing this out, you'll continue to learn more and more about this. I'm showing you this because it can help you so much for your assignment that I'm giving you. Just a hint, the assignment is pretty simple, but there's some questions I put there to jog your memory or to basically test out your creativity so that you can also push yourself. I don't want to give you something that is so simple at the end of the day. I want you to sweat a bit because that's the only way you'll be able to learn and actually interact. Such that the feedback I give you would be more personal, such that depending on what you want, I can give you guys feedback via email, or we can just set up a call individually with me going through the assignment and what you've done so that we can also discuss it and maybe correct a few things here and there. We might do the corrections early next year, because I want you guys to enjoy your Christmas break. So in January, I'll be setting up sessions with you guys individually, discussing what you guys have been able to come up with for your assignment and tell you exactly where you've gone wrong or where you've done really well as well. That's basically the model that we want to use for this particular bootcamp as well. So that's it for Openzeppelin contracts. I feel like I've talked a lot. Have I lost anyone until that point? Is there anything you want me to go over again? Hello? Is there anyone who I've lost?
No, I think we are okay.
All right, perfect, awesome. On a scale of 1 to 10, how are you feeling? 1 being you're not understanding anything, 10 being like you're up to speed, you understand, and you're good. So just type in the chat between 1 to 10 how you're feeling. It's also just helping me gauge how guys are doing. Manual 10. Yes, it'll be a strong assignment. I trust you guys. You guys are smart. You're sharp. Okay. Njakai, how are you feeling? James, how are you feeling? Okay, I'm seeing James, you've also written a comment. You need to do more. Tell me after writing your own contract. Or Mark, missing out some key points. Okay. Okay. Mark, what would maybe were you missing out on? Maybe some things are a bit confusing.
I actually joined late and I don't know where exactly you people started. So that's where I just joined and I saw codes just on the screen all over. I don't know where you people started.
Okay, no worries, no worries. I'll just finish up and do a brief recap for everyone again, just to go over a couple of things as well. So yeah, cheers. So that's it in terms of how Openzeppelin works. Then, so for this one, I'm just going to deploy this. So this contract that I created here called NFT only has one function for minting the token. For you to mint, it only takes in one variable, which is the URI. A URI is basically like a link to the source of the image. Because of the data intensity of images in the blockchain, you don't want to store them directly on chain. So what you store on the blockchain is a reference to that image, which is stored somewhere else. So when you're taking the image, I make sure that the return type is public so everyone can see it. Then I implement my increment. So I give this, what's it called? A token ID value of a random number that's incremented. Then I create a new variable called new token ID, which I then say is token ID current. The reason I'm saying this is because over here, when you create this ID, let's say I minted a token yesterday and a token ID was created, that token ID will remain the same when that function is called again. So I need to increment it, then set the token ID for my new token to the current one so that it doesn't use the previous one, where you end up having two NFTs with the same token ID. That's basically what's happening here. Then for me to mint, I need to know, okay, for this token that I'm minting, who am I sending it? Who is paying for this particular transaction? That's who the sender is. And what is the token ID? The token ID will be this one we've created here. Then I set it such that it's approved for my marketplace, so it can be listed there. Then I set it to true. Then the last part is a function called emit. No, the NFT minted, I mean. So you emit, or basically you create this new token with this token ID, which will also have this string memory that's been put over here. It's pretty straightforward because a lot of things have been abstracted. Most of these functions we are calling have already been defined in these smart contracts we've imported up here through Openzeppelin. So if you want to go through more of their specific implementations, you can read those specific smart contracts in here on your own as well. So that's basically what's happening there. Then for the marketplace, which is a bit more lengthy, is where you'll have the magic happening. So I know you're asking me about, okay, so you want to ask yourself, where is the token ID? Where is the seller, owner, price coming from? So the marketplace itself has these particular structs. There's a struct for how the NFT should look, how the NFT should be listed as an event. So actually, let me briefly pause. Did you guys talk about events yesterday? Not yesterday, on Thursday.
And no, we didn't talk about events yesterday. Yeah,
Okay.
well, I think I know about them.
Okay, let me just go over that briefly as well. So when you're interacting with smart contracts, it's important to specify how those interactions should occur and basically how it should look in that sense. And that's what the events allow us to do. So structs are important, but so are events. So in this case, like if I'm using this example, the events that I have is this is the data that is being modified when an NFT is listed in the marketplace and when an NFT is sold. So this information is pertained to one specific NFT. So these events will be mapped out to this NFT structure. So an event is mapped out to a struct or the objects of that particular struct. So if this happens to that object, this data is updated. And I'm going to show you how that works in the later functions. So the constructor only takes in the sender who's paying for this marketplace contract to be published on the blockchain. That's basically what it does. Then in terms of the function for listing the NFT, it basically takes in the address of the contract for the NFT, the token ID, and the price. Then it's public and it's payable. Payable means that there's a particular fee that will be charged for this NFT to be listed in this contract. Then no re-entrant. Let me explain what this means. This is tied into the re-entrancy guard that we are extending from the re-entrancy smart contract. Long story short, yeah, it's a security feature for smart contracts. You can continue reading about it on your own. What it means is, let me see. I don't know how in-depth you guys have gone into Web 2 development, but when you're dealing with algorithms, you maybe you've heard of things like round robins and the likes. But if you haven't, I'm going to, let me see if I can, let me use a simple example. So let's say you're going to a shop, maybe you're going to KFC. And it's a self-service KFC. It's a futuristic KFC shop. Maybe you want a KFC burger or like a classic chicken box or something. You go there, you make an order, then you say that you want to pay. So when you click on pay, you ask yourself, how long does it take for my payment transaction to be confirmed? Is it 10 seconds? Is it 30 seconds? Is it 1 minute? So let's assume that it is 10 seconds. And maybe I'm a client who's a bit IT savvy. I can come and I can tell myself, okay, I know it takes 10 seconds. What happens if I make the same order twice, but I make the second one before the 10 seconds is up? What will happen then? Does it mean that I can have two orders for the price of one by manipulating the system? So then you sit down and you think about it, maybe for like a week, a month. You're scared, you're like, hey, I can do this, it can work. What if I get caught? I go to jail, something like that. So maybe you get the courage and you do it, then you find that it works. So it's a simple explanation, but that's exactly what was happening with smart contracts before people started thinking about security. People are manipulating the NFT marketplace contracts. You're publishing as many minting or maybe buying transactions quickly such that you're only paying for one specifically before another one is charged. So the re-entrancy guard contract was a feature that has been added to secure smart contracts in the future. So it's a standard that you need to get used to using whenever you create a smart contract. That's basically what that means. Are we good until there? Have I lost anyone? Okay, I'm assuming you guys are good. So as I wind up, the final thing now would be in terms of this. So you have to put these particular requirements. So for me, I've said you can't list an NFT with a price of less than 0. It must be at least one way. So what I'll do is actually update this, because I realize it's actually a bug. So it should actually be less than 1. Let me do that. Then I say the message the value should be equal to the fee. So saying not enough Ether for the listing fee, such that if it's below this, this is the message you get. Then you'll call the ERC 721 contract file that you've imported here. Then you basically now transfer from the sender to this particular address and the token ID. So once you've done that, you increment the counter in terms of these are now the number of NFTs that are in this marketplace. Then you map the ID of this NFT to the object based on this construct we have here, which is what is happening here. So you put in the values of the NFT contract, the ID, the sender, the receiver, the price, and true being the value of whether it's listed or not. Then you emit, or now you list this NFT using those particular fields again. That's basically how you list it. And on that note, I'm gonna add a link to these smart contracts that I've written here, so you guys can also reference them during the assignment. So you also, maybe if you feel a bit stuck, you can just look at what I've done here. Then same concept for reselling the NFT. You take in these particular features, make sure it's public, it's payable, and there's no re-entrant. Then you say not enough ETH for this listing fee if the value is less than the fee that was specified for you to list an NFT. Then you transfer this particular NFT from the person who's sending it to the person receiving it. Then you set the same values that are there in the struct and change them here. Then you can also have the counter which you created for the number of sold NFTs, and you increment and you reduce it to maybe 1 if you want to resell it and the likes. Then the emit function is always standard for this. Then there's also the function for buying the NFT, which basically goes through the same logical procedure of creating a new object based on the structure, inputting those particular values, and calling the functions that are imported from the previous contracts. They can also fetch the fees. The rest are just additional functions that are a bit advanced, but you guys can continue reading them or not, because I've been modifying this smart contract over time. So the other functions that you may see here that are not relevant, but I'll just leave them here in case you want to go through them as well. So I'm just going to go ahead and compile them. So I'll compile the marketplace contract first. Hopefully everything is good and working perfect. Then I'll go ahead and compile the Craftly one as well. Then I'm going to deploy them. So for me to deploy this marketplace one first, let me deploy market first. So let me deploy the marketplace contract. Okay, so I've deployed the contracts twice by mistake, but anyway, it is what it is. So I'm gonna copy this, then go ahead and deploy the Craftly one, which, like we mentioned before, I need the address of the marketplace to deploy it. So if I add it here and I deploy it, it should be fine. So I've also deployed it twice by mistake, but it's all good. So once you've done that, if you want to interact with these smart contracts, for example, I'll just click on the drop down for the marketplace. Actually, really, and you can see all the functions that you can use. You can buy, you can list, resell, check the fee, you can get the listed NFTs, which they are 0, I'm assuming. So if I call this, I don't know, I'm not seeing the terminal. Oh, so actually it was calling. So if I look at the fee, this is the fee for publishing an NFT using my smart contract. This is the listed NFTs being 0. This is the fee for listing an NFT. Getting the NFTs that I've listed with my address is 0. Then getting my NFTs, you'll find that they're 0 since you've not used it. If I want to resell or buy an NFT, I'll have to input all of these particular values here as well. If I want to mint an NFT, I can use the Craftly NFT that we've just published, and these are all the functions that you can interact with as well. So that's just a look at how it does it. You can see the number of the tokens also went down because of publishing, but to do that with Ethereum is also pretty straightforward. If you want to use a wallet as well, but this is basically what is happening here. So if I'm to go through the assignment, I know some of you guys are worried about, okay, I've done this first, I'm expecting you to master everything. No. In the assignment, I've listed all of the steps that you guys need to do this. For example, I'm assuming that you don't have Metamask. So in preparation, there are steps to set up the wallet. There are steps to connect to the Goerli Testnet. What I'll do is I'm going to update this section here. Let me just highlight it so I can remember. I have a meeting after this. So I want to do this immediately, but I'm going to update this so to make it easier, because some people may have challenges doing it manually. Then how to fund your wallet using the faucet. The steps are here. Then also an explanation of how to set up Remix and create your own workspace and upload smart contracts. There are submission instructions here for how to connect to your GitHub, as well as how to create the access tokens. Then also the link for the submission form where you will be submitting. I'll just need your name, your email, as well as now the link to your GitHub for your particular smart contracts. I've put this here because this is important. You won't get a certificate until you submit this assignment. And the deadline is midnight on Saturday, as is listed here. And what your assignment is basically creating an NFT bookstore. It's based on my smart contracts for Craftly, for the NFTs marketplace. But I want to see how creative you can be with that. Examples, for example, you create a bookstore NFT and also a marketplace for those books in that bookstore. And you should be able to sell, buy NFTs and list the ones that are in the marketplace. The objectives are just to see how you can implement the ERC 721 NFTs, how to create a marketplace, how to handle the ownership, pricing and transaction, and the transactional security, how users interact with their own NFTs, and also just minting, listing, and selling in general. So yeah, just steps on what you need to do and the deliverables as well. Okay, for those of you guys who don't have any mainnet ETH, what you can do is, instead of using let's see what we can do. I'll give you the option of just minting using these particular options here as well. You don't have to use a MetaMask wallet if it gives you a challenge. I'm more interested in the smart contracts you write, because I'll be deploying them on my side as well, just to see how I can interact with them as well. I'll upload them to Remix and just do an audit of your smart contracts. I hope that answers your question, Kevin.
Yeah, it does. Thanks.
All right, so that's it for the assignment. I'm sharing the link here, but you'll also receive an email from the team about this as well. So let me just share this link with you guys. So put the link in the chat so you can copy it as well. So happy hacking, happy coding with regards to this assignment. If you have any challenges, text me. I may respond a bit late because of time zones, but I'll still give you guys a response in case you have any questions. So cheers, thank you for your time as always. Maybe if you have any questions or comments, feel free to let me know before I end the call. Okay, assuming you guys are good. Happy holidays. Make sure you do the assignment, then we'll be able to discuss it as well. Thank you guys.
Thank you, sir.